Hi guys, Kim here, Papa's Fix the Shop. So first on this bit I want to address a comment from a subscriber. Someone called Systems Planet commented that they want to hear me narrate instead of playing music. Well, you know, that's awesome. I love comments. And I thank you very much, whoever you are. I really appreciate it. And keep up the comments. That's how I improve. I've often said that if I don't learn something new every day, I've failed in some way. It's a good thing to live by. I like music. And I put pictures up. And, you know, I play music when there's too much machine noise and stuff. Plus, people have often told me I talk too much. So I appreciate somebody telling me I don't talk enough. That being said, this is going to be a non-music video. Partly because of Systems Planet's comments, but more importantly because the subject matter this time is much more detailed. And I'm going to explain the major failure that occurred yesterday when I was trying to cut this cutter shaft, you know. Bear in mind, I have OCD really bad, and even a tiny deviation can drive me crazy. So there was another comment, and I can't remember who did it, but might be the same person, but it talked about how hard it is to build this thing. Yeah, it's a lot of labor. There's also probably 25 or 30% of that labor is me doing things that don't need it to be done for the functionality. I like things to look good and be smooth and try and get my numbers to hit. But more importantly, this part, the main part with the motor and the drive and all the stuff that it works together, is a prototype unit to test a concept. So if I was going to mass produce this, I had any intention to mass produce this, it would not be done this way. It would be quite streamlined. The reason I did it this way is because of the cutter shaft. This is designed that it's fairly simple to pop the shaft out and put another one in. Because quite frankly, we're aiming for a specific target of making a cut pellet from the cast-offs from 3D printing that is in a size range that the extruders that these guys use to make filament like those pellets. So, you know, you can cut up plastic all you want, grind it with a shredder, get a, you know, whatever, but if the pieces are too big, too small, too irregular, then you still have a lot of waste, at least in my understanding. Bear in mind, I'm no more a 3D printer guy than I am a machinist. You know, I've been clearer from the front. I've been playing around with these machines for 5 or 6 years. So I'm trying to keep busy, and if somebody gives me a project, I'll take it. Even if I'm not charging $100 an hour, which is, I mean, I don't need that. I'm retired. I'm going to explain this shaft in the next part of this video, but it's a classic example of paying too much attention to numbers and theory than to what you're actually doing. And I made a mistake at the very beginning and pretty much came close to me thinking, well, you know, how long would it take me to get another piece of steel and do this whole process? Mental flatulence. This is a work in progress, and I appreciate everybody watching. I appreciate everybody commenting, asking questions, making suggestions. So this is as good as it gets. So hope you enjoy this next little bit, and who knows, by the time I'm done, because I'm right here now finishing this shaft, I may have a working prototype that I can actually try and shred some plastic with, because all I really have to do is finish this shaft and put it in this box. Thanks for paying attention. There goes nothing. Apparently the radio is looping David Bowie Let's Dance, and it knows what I'm getting ready to do right here. So, and anyway, Alexa, volume 0. I don't want to have to just delete my commentary if there's somebody singing in the background. Let's see if that much is going to fly. But here we go. So, got my y-axis set to 0, which is centered on the bar. The direction of rotation for cutting will be this way, so I need to make a step on this side, which is the first part of the, I got to take a notch right here, like this section. I got to do this one and this one here. Here goes nothing. Finish it or scrap it, right? Oh, that won't do. Oh, let's go all the way up. So, what's going on here? Thought I had my z-axis zeroed out. This goes into my old saying that if you ask yourself if it's going to work that way, it won't. You better go back and figure it out. So there's y at 0, and it's about where it's supposed to be. The z-axis. There we go. Start at 0. I'm going to take like half a mil just to see how it cuts. See that? That little end mill fell down. That's because I never tightened it. And I was getting ready to break a carbon end mill. If I was just looking at the DRO and not at the end mill, I'd have a $40 piece of shit. Damn it. Stand by. All right, let's continue with the end mill. Actually tightened into the arbor there. So, into the holder. So it's the day after I decided to cut this thing, and I said in the beginning I needed to know how to do this, and clearly I don't. I started out with a lot of calculations to try and make sure I knew the sequence to cut to get everything perfect. And I did it with a lot of math, and I tested it and retested it, checked it, and then proceeded on the first 5 cuts to make a 2 millimeter error. And that error originally had 5 teeth. That error, since there were 4 separate webs here that had the exact same coordinates to cut, the first cut of the 15 that were planned, or well, 15, no, 4 times 5 is 20. So I was, I could do all of those one at a time and they'd be identical. So I started by doing the first cuts across 4 of them, and then rotated to the first one again. Fire truck. So when I got to the 5th cut of that plan 20, it was the next one around on this guy, and it became obvious as soon as I cut it, while I was busy staring at numbers, that there was not enough room with that error included for 5 teeth. So then it's like, did I scrap the part? Well, I made a decision on the fly to switch to 3 teeth. First I tried 4, but the error was big enough that it precluded any chance of getting 4 teeth. Not even 5, not 4, maybe not even 3, and the result is that, let me turn this guy. This guy right here, I'm going to profile it, but it's so thin, I might just cut it off because if it breaks in there, it could cause more damage than anything. So, yeah. And then as a result of all of that, even doing a 3-tooth pattern, because of the 5 or the 4 webs that were disrupted, I ended up with a pretty random arrangement of 3 teeth around there, and I pretty much am missing 1 tooth. So, yeah, I'm going to do a little video of me. What I'm doing now is I've cut these flats. You see a flat right here? And there's another point I'm going to come in with a ball end mill and go in here and make a curved surface, like a radius on the inside of the teeth. But now, right at this point, I'm actually doing the reliefs on the back side of the teeth, because you need enough bulk of metal on the tooth to handle the load, but too much of it interferes with the stuff getting into the next teeth. So that's what I'm doing right now. So here we are at the end of this shaft that has kicked my ass. Figuratively and physically, I'm kind of sore for all this cranking and stuff. But I'm on the last 3 teeth. And after that, I just got to go along here and check all of these roots on every one of these teeth to make sure there's no sharp edges. Let's see if I get in close. Like down here, there's a little lip. It's hard to see, but it's positioned, so I'm not going to turn it. But every one of these little radii that come around these teeth where they hit the shaft, any kind of straight line there is an invitation for a crack formation. So I'm going to try and clean them up. Oh yeah, there's a good one right here. You can see it in the camera. If I can hold my hand steady right here. So, still a bit of work on it, but we'll see. I'll take a video of it right now while I'm cutting it. this particular setup with this is a 6mm 2-flute ball end solid carbide end mill from Niagara, and at least with this setup, it likes climb milling much better than it likes conventional. So I take it really easy when I'm doing conventional. Let this, hear it humming. I'm going to take the same amount and go back while I'm climbing. See, it's just almost no difference. Stop and take a look at my route. That's the trick. Okay, then what I do is I have my DRO set at to where 0. I'll show you. It's easier to show you than explain it. So I did this tooth. The DRO is set in the y-axis at 0. So I move it to 0, near about. And then I unlock this guy and I rotate this guy around till it goes past the end mill. And then I lower the end mill down to where I find my 0 on the DRO. So the point is, every cut, I end the cut at 0 on the end mill, in the y-axis and the z-axis. The x doesn't matter, it's just me moving back and forth. So once I get to there, I bring this guy up until it just touches the end mill. And there should be a hole in the indexer at 5mm increments that it'll find right there. If it doesn't find the hole, because the holes are kind of like 15 degrees apart, then it's at the nearest 5mm point to where it lands. And that's how it's seat of the pants stuff. So here we go again. What the hell? I'm always looking for my coffee. It's freezing. Freezing cold here. In the deep dark dead of winter. I think it's like 70 out. Anyway. Okay, I'm about to do the last assembly of this well, probably not the last assembly, but I'm going to put it together and test it. Technically, the only thing I have left is this cutter shaft, is to answer the question on whether I should heat treat it and temper it. So the Rockwell rating of the plastic it's designed to shred is, it's like 128 or something like that. It's pretty soft. But I want to see what the teeth do. I'm going to explain that heat treater probably later. Get off subject and start to ramble, and people will tell me I talk too much. So these are all the parts. Basically, not including fasteners, there's 20 parts here. There's the main frame or the box. This is the fence, gate, whatever you want to call it. It's for the adjusting how much it can cut at once. There's a shaft. The two bearing blocks that go on the end. This is black foam, like half-inch, low density, closed foam insulation. And these fit in a space between the ends, right against the bearing. And it's so that chaff can't build up in these cavities. And then there's a bushing in the middle of that, of each of them, a distinct bushing, that is also a barrier for the chaff so it can't migrate between the cracks. And then they have this little guy on each of them. How about I zoom that in? All right. So here's one of these side plate, seal, gasket, whatever you call it. On the side that faces in towards the plastic, I put Mylar tape. It's just harder for stuff to stick to. That's the only reason it's there. And these two little bushings. Oh wait, there's a piece missing. Where is it? Oh, there she is. And there's a shaft. The shaft goes through there and has these bushings on either end that keeps this guy spaced correctly so that the cutters can go through the middle of the fence. It's actually like this. Essentially, this positions this so it can't move side to side. So that's a set. And then, of course, this is the cutter support block. This is the cutter, the stationary cutter. This is the knob to adjust the depth. This is the plate that retains the knob that adjusts the depth. This is the depth adjusting bolt rod. There's a key and a link that connects it to this guy right here. So that's the whole thing in one bit. I'm going to put it together now and see what happens. Well, let's see. Power on. It's kind of selective on the size of what you put in there, but I find if I break stuff up, and that's a solid chunk almost. Let's give it some more. Open the teeth up a bit. Yeah, stuff that's flat, it don't quite lay in there. Okay, so this is like temp test. This is a triangular shaped piece. Let's see what it does. was like 40 seconds. Nice. If I put too many in there, they fly all out. But I've been testing the shapes. And it's pretty much down to about, you know, call it a 1/2 inch in any direction, 13 millimeters. Works best. Let's see, like this guy is a little big. It's got these things sticking out and they just end up making it straddle. So this is at the widest setting of the teeth too, by the way. There it went. So this works, you know, cuts them down. It flew out and went right in the trash can. Okay, here's this thing. It's got a bunch of chips in it. Put this box over it. Go backwards. Oh yeah, starting to grab them now. That wink wink noise is some misalignment that I managed to introduce welding the bearing caps on. Gonna have to live with it. So you can see it stop cutting. Still stuff in there. Flip them around a little bit. This stupid speed control. Whoop. See, that was jammed. The speed control took a crap like 30 minutes in, and at least it failed on full speed and not low speed or something. You have to watch it the whole time because it'll grab one and jam. And you got to turn it. Oh, shit, it's almost gone. Ooh, grab one immediately. One chunk left in there. Guess it works.